we are going to do another question, which is find the dimension of A and B. So we have two equations. The first equation is actually mu is equals to A plus B by lambda squared, where lambda would be the wavelength, mu would be the refractive index. And so now the second one is V is equals to A E minus B T squared. So here V is actually velocity, so it's velocity in this case. So now let's solve it. So we are gonna first of all do the first one. So let's do the first one. We have mu is equals to A plus B by lambda squared. So from principle of homogeneity, we know that the dimension of mu, which is refractive index, will be the same as the refractive index of A, which will be the same as the refractive index of B by lambda squared. So, and which is actually 1. You can write it as 1, or you can write it as m to the power 0, l to the power 0, t to the power 0. So that's the dimension. So if we have to find the dimension of A, we've just found it. So the dimension of A is m0, l0, t0. And to find the dimension of B, we will have to just do this. So we know that the dimension of B must be the same as the dimension of lambda squared, which will be m0, l0, t0. So the dimension of lambda is, since lambda is wavelength, which is a length, it will be length. So length squared gives us m0, l0, t0. So which means B must be equal to L squared. So we found both A and B that we needed. So the dimension of A and the dimension of B was found. So now let's move on to the second question, which was V is equals to AE to the power minus BT. So again, from principle of homogeneity, let me change the color of this to white, and over here too, so that it's clear that the question was about this. So now from principle of homogeneity, the dimension of V must be equal to the dimension of AE minus BT. So also the dimension of V is, and this will also be equal to the dimension of A, since exponential function. So E minus BT is in the form of an exponential function. So this is an exponential function. So exponential function which does not have a dimension. That's why we can write only A as well. And since the dimension of velocity is LT minus 1, we can say A is equals to LT minus 1. So we are done with this. So since e to the power minus bt is exponential function, it is dimensionless. So bt is also actually dimensionless in this case. I'm sorry, it's supposed to be square. Did we write square over here? Yep, we write square over here. So here minus bt squared is also dimensionless, which means minus bt squared, the dimension of it will be dimensionless, which is m0, l0, t0. So now we know that the dimension of b, so the minus can not be written since minus is dimensionless, will be the same as and the dimension of t is t, which will give us m0, l0, t0. So let me write in another page. The dimension of b turns out to be t minus 2. So we found the dimension of both a and b. So we found the dimension of a right over here and the dimension of b right over here. So suppose we took an exponential function. Suppose this is an exponential function. here the dimension of A is the same as the dimension of B, and which are both dimensionless. So you can write it as 1, or you can just write it as M0, L0, D0. So this is something that you must know when talking about exponential function. So this is an example of exponential function. So that was it for today's video. In the next video we are going to do some more questions.